Learn like a pro.
We are surrounded by this invisible force that powers literally everything in our world. But have you ever stopped to think about what keeps that power from becoming a deadly hazard? Today, we're going to pull back the curtain and look at the hidden engineering that keeps you safe from the electricity humming inside your walls. I mean, think about it. We use it every single second of every day, and we don't even give it a second thought. But electricity, it really walks this razor-thin line between being incredibly useful and incredibly dangerous. So let's dive into the ingenious systems that are designed specifically to keep us on the right side of that line. All right, so to really get a handle on the defenses, we first have to understand the enemy, right? We have to meet the villains of the story. And it turns out, there are three really common ways that a perfectly safe circuit can suddenly become a huge threat. Okay, first up, damaged insulation. You know that plastic coating on every wire? Well, that's its armor. And if it gets frayed or cracked, that live wire inside gets exposed. Now, if that bare wire touches something it's not supposed to, like another wire or maybe the metal casing of an appliance, boom, you've got a short circuit. And that is a recipe for some serious heat and, you guessed it, fire. Threat number 2 is overheating. And we've all been tempted to do this, right? Daisy chaining a bunch of extension cords together. When you try to pull way too much power through a single wire, it heats up a lot. Get it hot enough, and that insulation will literally just melt away, exposing the live wire and creating the exact same fire and shock hazards we just talked about. And last but not least, threat number 3, water. Okay, now here's a wild fact for you. Pure distilled water, it's actually a terrible conductor of electricity. But the water that comes out of our taps, totally different story. It is chock full of dissolved salts and minerals. And those little impurities, they turn regular water into an absolute superhighway for electricity, creating a deadly path from a faulty appliance right through your body and into the ground. And that really brings us to the most fundamental danger of all, which is you, or me. Our bodies are just conductive enough to become the missing link in an electrical circuit. That's literally what an electric shock is, and it's also why something as simple as rubber gloves works so well. Rubber is an insulator. It's like putting up a giant roadblock on that electrical superhighway. So, we've met the threats. How do we actually fight back? Well, our very first line of defense is built right into the power cord itself. Let's take a closer look. Let's go ahead and crack open a standard 3-pin plug. When you do, you'll see it's not just one wire in there. It's a whole team of 3, and they're all working together. So let's meet the crew: the live, the neutral, and the earth wires. So you've got the live wire, usually brown. That's the hot one. It's bringing all the high potential power in. Then you have the neutral wire, which is blue. That's the return path, completing the circuit back at a super low potential, basically 0 volts. And then you've got the earth wire, the green and yellow one. It's a dedicated safety line that pretty much just hangs out, acting as a bodyguard. Now, what's really fascinating here is how this maps out the electrical pressure, or what we call voltage. The difference, the potential difference, between that high-power live wire and the zero-power neutral or earth wires is a whopping 240 volts. That's the force that's pushing the current. But look, between the neutral and the earth, there's no difference at all. They're both just chilling at ground level. Okay, so now that we know all the players on the field, it is time to learn the single most important rule in the entire game of electrical safety. This is the big one. So here it is, the crucial point. Any safety device, doesn't matter if it's a switch, a fuse, a circuit breaker, it has to be placed on the high voltage live wire, not the neutral. Never, ever the neutral. And this slide just illustrates perfectly why that rule is so critical. Look, if you put the switch on the live wire, when you flip it off, you completely cut the appliance off from that 240 volt source. It's dead. It's safe. But if you put the switch on the neutral wire instead, sure, the current stops flowing, but the entire guts of the appliance are still sitting there connected to 240 volts, just waiting for a new path to ground. It's literally a high voltage trap. So what happens when something goes catastrophically wrong inside an appliance? Well, that's where our bodyguard, the earth wire, steps up to perform the ultimate failsafe. Just picture this. There's a fault inside your toaster, right? The live wire comes loose and it touches the metal casing. Now, without a defense system, that entire metal body becomes live at 240 volts. It's just sitting there, waiting for someone to touch it and complete that deadly circuit to the ground.
But the Earth's system gives us an engineered bypass. That earth wire is connected directly to the metal case, and it offers a path of almost zero resistance back to the ground. Electricity is lazy, right? It always takes the easiest path. So when that fault happens, the current doesn't wait for you. It immediately rushes down the super easy path, bypassing you completely.
And this triggers this incredible life-saving chain reaction. 1. The fault creates a massive surge of current down the earth wire. 2. This surge is so huge that it instantly melts the tiny wire inside the fuse on the live wire. And 3. The fuse blowing breaks the circuit, killing the power in a fraction of a second and making the whole thing safe again. It's genius. Now, this life-saving idea of tripping a circuit when things go wrong, it doesn't just work inside one little appliance. No, it's scaled up to act as a guardian for your entire home.
This is your home's main defense hub. You probably know it as the fuse box or the circuit breaker box. This thing contains multiple layers of protection, like all these little switches, which are called miniature circuit breakers, for different parts of your house. And while a fuse, which is inside a plug, is kind of like a one-time use device that sacrifices itself to save you, a circuit breaker is like a reusable fuse for a whole section of your house. Instead of melting, it's a mechanical switch that just trips open during a surge, and then you can just reset it once you've fixed whatever the problem was.
You know, it all really boils down to this one simple, incredibly powerful idea. All of this amazing engineering, the earth wire, the fuse, the circuit breakers, it's all built on a single promise. When things inevitably go wrong, the circuit dies before you do. The whole system is designed to fail safely, every single time.
So the next time you go to plug something in, just take a second to think about those silent guardians, both inside the plug and in your walls that are just standing by, ready to keep you safe. Makes you wonder what other invisible engineering we rely on every day, doesn't it?